We dedicate this video to our beloved brother and astrophysics enthusiast Sushant Singh Rajput. He is just beyond a powerful actor. He didn't stay with us for a long time, but his smile will be always shining in our hearts as always. Hope he is in a better place now and keep inspiring as always.
Black holes, neutron stars, pulsars. Our universe is full of fascinating mysteries. But there is one fundamental thing that governs everything in the universe. This fundamental thing is responsible for answering the questions: what holds the heavenly bodies in space without making them even fall? What causes planet revolve around the sun? Or why does not time gets backward? The space-time, fundamental architecture of universe, space beyond 3 dimensions. Let's start with how our universe was born. The Big Bang. Before the Big Bang, our universe was at the size of a grain of sand, packed with immense amount of energy and unimaginably dense. This densely packed energy powerhouse suddenly collapsed, releasing enormous amount of energy as a shock wave in a fraction of time. And it is said that this happened with the speed greater than the speed of light. We all know that the ultimate limit of speed in the universe is the speed of light. But we should remember that this is before the creation or at the time of creation of our universe. The energy waves moved outward from the site of explosion in all directions, theoretically speaking, in a spherical fashion. The path traced by these unimaginably high energy waves is what we call the space-time. Having known the fundamental architecture that governs the universe being space-time, let us imagine the instant at the starting point of Big Bang. All the high energy shock waves emanating from the result of Big Bang were identical and shared same properties like velocity, energy density. This resulted in a path at the space-time which is perfect in all the dimensions without any distortion. However, this perfection of space-time was not long enough. Just after the instant of Big Bang, the high energy waves loses its identical properties, that is, energy density and velocity of the resultant waves started to change. This resulted in faster waves hitting over the slower waves continuously and in an unimaginable scale. A genius once said that matter and energy are different manifestations of the same things.
Followed from the special theory of relativity that mass and energy are but different manifestations of the same thing.
Waves started to be converted to particle. The particle has mass. The mass eventually bends the space-time fabric. This in turn brings more and more particle onto the same particle and forming a bigger mass, eventually forming an element and finally resulting in the formation of heavenly body called stars. These are heavy enough to be noticeably distort the space-time. Imagine this distortion is happening in a universal scale. This is what we call warping of space-time. The warping of space-time fabric answers a significant phenomenon. What causes planets to revolve around the sun? The curvature of space, owing to its geometry, makes the planets spiral around the star, sun in our case, before it finally collapses into the star. This force, which exhibits between planet and the star, or which interlocks the star and the planet, is what we call gravity. This is the same that exists between a moon and the planet. Now comes the question: how did we first identify this mysterious force, space-time, when it is totally invisible and unnoticeable? And who discovered that? Albert Einstein. When he was working with his general theory of relativity after success of his special theory of relativity, during his calculation, he found an astonishing discovery that heavy objects are capable of distorting the way the universe is supposed to be built. The factor that governs the supposed to be built is what is called space-time. What is the proof that space-time even exists, though it cannot be proved directly? To prove that, it is enough if we prove that space-time can be distorted. Massive objects in the universe tends to bend the space-time fabric. This has the tendency to bend light even. This bending of light was first visualized by Albert Einstein. He picturized the image of a distant star. In the first image, the light was coming directly from the star to Earth, so ultimately there is no bending of light. In the next image, the light was coming from the star to Earth, crossing our massive star, that is Sun, on an eclipse day. To his surprise and anticipated calculation, taking into account the rotation and revolution of Earth, the position of star which he was investigating changed apparently, though it should be on the same position. This proves that light bends around the heavy object, which is the Sun in our case, owing to the bending of space-time fabric. There is another way by which the bending of space-time fabric can be proved, by measuring the bending of space-time itself. This was done first in the year 2015 by LIGO Observatory. They measured the ripples in space-time directly and converted it into a sound. That was the first time in the history of mankind we were able to detect the ripples in space-time or the gravitational waves directly. That was an immense proof of Einstein's effort, proving that there is something called space-time existing in the universe after his successful proof of gravitational lensing. These distortions in space-time can have an effect on the time itself. Whenever a massive object expands the space, then the time around it stretches, which means the time appears slower compared to the nearby areas where the space is not stretched. On the other hand, when the space is compressed, the time appears to move faster compared to the place where the space is not compressed. There is another important question to be answered. Why does the time never goes back? To answer this question, let us take the Big Bang explosion. During this Big Bang explosion, the shock waves are radiated outwards in the direction of the universe expansion, thus formulating the time always goes forward. If in case there is a chance that universe shrink beyond the point before the start of the Big Bang explosion, then the time may go backward.